know SQL, you know T-SQL, you know select, you know from, you know where, and it works. But when you have time series data, hundreds, thousands of events every second, SQL hits its limit. KQL thinks differently, not as a set, but as a pipeline. Today we will learn what that pipelines look like and why it's so much more powerful for streaming or continuous data. Let's start straight away. This time we have much more complicated drawing, and so I found it might be easier that I've pre-created them and draw on top of the diagram and not drawing the diagram. This will be an exception, of course. So let's have a look how that works and how the KQL where the KQL query set sits in that ecosystem. So on the right side we have the event house with our KQL database. This is where the data sits. We have a bunch of data sources like an event stream, for example. And this event stream writes into the event house, and from there we can access it with the query layer. And we have three distinguished ways to access the data. The first one is we can go with the SQL endpoint. The problem is not SQL. I love SQL, everything is great, but SQL doesn't have all the commands that you would need to really query streaming data. We have notebooks with Python and KQL Magic, works great, but it's code, writing a lot of code, right? And you have performance questions and so on. And you have the KQL Queryset, which uses KQL. This is a primary exploration tool to explore the data. From there, you could also access the Azure Data Explorer, and Azure Monitor both support KQL2. Regarding the outputs, we have one output that directly or natively supports KQL Queryset. These are real-time dashboards. And of course, we could use Power BI dashboards with notebooks or with SQL endpoints. And from the KQL database, we can go to the activator in a direct way. But when we want to look at the KQL data set, and there is the easiest and directest way to go with a real-time dashboard. You can even save as real-time dashboard, save as real-time dashboard directly in the KQL query set. You could use SQL, but well, let's make a comparison. I have one chart here. I'm so used to draw that stuff, so I'm not used to find that stuff. Where is it? Give me a second. Let's create a KQL query set. It's fairly simple. You hit on new in your workspace, filter by query, and you get the KQL query set. You have to name it. You can select the location, which is the workspace. And well, that's your starting point. You see, you can add a data source, like for example, a KQL database, which we will do. In our case, we will select the RTI demo database. Pretty straightforward, and we get always this like intro dialog that you can read if you want it. We get some meaningless sample code in there. You see the weather sample data on the left side, and we can simply say weather pipe to take 10, not top 10, take 10. It's just the first 10 data in a row, and we can enhance our query a little bit, like from where start time is like 30 days ago, where state equals Florida. In this data set, it's a little bit special that we don't have data just 30 days ago. It's like almost 20 years ago, the data. So we need to adjust our query a little bit, well, and now you see you have only the day parameter here, so you need to apply a multiplier. So 20 multiplied with 365 days equals 20 years. And then we will get the data from 20 years back. This will bite us a little bit on everything, on every graph that is rendered on the timeline. You will see that later, but anyway, I think it's always clear what it's about. So now we sort by event count descending. So the highest event count from this weather events is now on the top. We can apply a little bit more, like summarize stuff with total damage, average damage, and put it in a bar chart. And you see all the data is there. I know it's quite small, but I think it's absolutely visible that you see, okay, you have it's like bar chart. It's sorted by total damage. It's the top 15, take 15 values, right? So now let's have a look at that explain stuff. And you see with explain we can I forgot the dashes there. I will do that. There we go. I found it. Well, next time I will draw again, but I think you get the idea. It's quite a lot to draw and write. So on the left side we have SQL, and on the right side we have KQL, and both assemble the same query. But you see, SQL is declarative, so it says what it wants. So it says from storm events where this condition is met, group by something, order by something, select. Yeah. So you declare the result that you want. KQL is pipe forward. So you say from storm events, do this. And from there, so where start time ago is 7 days. From there, summarize the event, count by state. And from there on, sort by event description. From there on, take 10 or top 10. And from there, render bar chart. So you see, this is like going from top down. And this is preparing the set that is queried in the end. Yeah. So they correlate, yes, but it's a completely different approach. The one is declarative, the other one is pipe forward. And this is the thing that needs to happen in your mind, obviously, in my mind too, right? It's like going from the declarative way, I want this, to do this step by step. That's the main difference. But of course, in this step-by-step approach, there's a big power to unlock everything that is stream-oriented or continuous data-oriented, because that doesn't work with a declarative approach. How does the KQL execution pipeline really work? In detail. So we start off with a table, which is raw data. So in this case, for example, storm events, 2.5 million rows, just as an example. Then we go to the where area, filter rows, where state equals Florida and start time is 7 days ago. It might give us 1,200 rows back. Next is we project or extend and shape the columns. So we say, okay, project state, event type, damage property. So we will get back 3 columns. And then we summarize, means aggregate, summarize total damages, which gives us the total damage, damage property by event type. We will end up with 12 rows. Then we can sort or top, sort by total damage descending. So the highest total damage on top. And in the end, we say visualize render bar chart. So you see, when you would draw it, it would look like a big funnel, right? Starting with a really big data set, getting smaller and smaller and smaller and more narrowed. This is the way how the pipeline of the KQL query execution pipeline really works. So now we will look at some more advanced dealing with time series. So let's say we work with events with a timestamp, device ID, and value. And then we create a query set, KQL query set, and make a series, a time series, average value per device 1 hour bins. So bins of 1 hour. And there we can extract with very simple KQL anomalies, flag outliners. And the same way we can say decompose our forecast projects next 7 days. And so we will can do that in just one query set, render time chart, visual and query results. We will see it in a second of the demonstration. And then with one click, we can push that to our real-time dashboard, pin to tile, save to dashboard, enable auto refresh, and we will get live data from the top down to the bottom without writing any line of Python. It's very, very intuitive and very, very powerful. Let's fiddle around a little bit with our queries, and you see we have again this 350-day issue that we need to multiply, and then you see the visuals from January 7 to January 8 with all the different event counts by state, binned by 1 day. And wow, I forgot it again. You see it there. So let's insert that. Now you see it biases a little bit. It's 20 years ago, but you see all the events there in Texas, Florida, California, just 3 states. So we condense it a little bit and render a time chart. We can do much more. So there we go. You see all the anomalies that we render in there, right? In that chart, and for Texas and anomalies and Texas normal data. So that's pretty powerful. How easy you can create a time series there and apply very, very powerful filter. So you see now the bin size is 1 day. And we create a time series at the target state, so it's a variable now, or kind of a variable, and then we just see the anomaly chart here with the storm anomalies. So it's pretty powerful for such a small text, and just keep in mind, that's a bit funny. Just keep in mind that this is also generatable by large language models. So I think it's really a nice way to get very, very powerful visualizations here. And we can simply hit Save to Dashboard. We need to provide a name for our dashboard. I'm not in a creative mode today, so I will pick the default. And after some seconds, there's a dashboard available. We can edit that dashboard, but then we will jump back to the KQL query. And we can test that KQL query. We can apply or discard changes. Which it's a little bit misleading, at least for me, because with this pencil, I always associate like edit the thing that I have and not the back end, right? But I want to change the tile, and you see that I have a separate point called rename, where I can essentially rename the tile. But this is the start point for our nice real-time dashboard that really levels up the whole experience here, and makes it very simple to get real-time data. So this is we can resize it. Yeah, this is when we hit update, it's updated, and we can also set auto refresh. Then it's updated automatically, right? It's under manage, and they see auto refresh. We can enable it, allow refresh intervals like continuous or 10 seconds or something like that, and it will work just right out of the box. And of course, there are new weather events at the moment that we can see. Last but not least, for this architecture part, our decision tree. I need to query my event house data. Do I have a primary language preference? Do I want to go with KQL or learn KQL? Do I want to go with T-SQL? So you see, then our journey is over. T-SQL endpoint, but we will miss a lot of cool stuff. Or Python. With Python, we can use notebooks with KQL Magic. When we want to learn KQL, we can still use notebooks with KQL Magic. When we do want to do complex visualizations, we can still use notebooks with KQL Magic. When we want to explore our data interactively, which is very often the first step, then the question is, do we want to pin that to a dashboard? Yes or no ends up to the same. We will go with a KQL Queryset. And there we have multiple tabs, save to real-time dashboard, we can share a query link, and we have Copilot assistance. So it's very straight. When you want to go SQL, stay with SQL, but you will miss all the power of time series. When you want to go with Python or KQL, and you prefer the notebook experience, for whatever reason, complex visualizations, data science, or just Python, you can go with Notebook and KQL Magic. When you want to do interactive exploration and even pin that to a dashboard, go with the KQL Queryset. And let's have a short look to our explain section. You see, explain converts the SQL to KQL. The KQL is written under there, and we can simply exchange the code, and we will see that it replaces similar results. Questions and answers from the community. First one, I know SQL and I'm confused by this KQL pipe syntax. I understand you. So yes, but I love PowerShell, so I can activate my parallel brain with PowerShell. I have 10 years of SQL experience, and I keep writing KQL like SQL, putting where before select, mentally forgetting the pipe, writing things like where timestamp is larger than get date -1 instead of ago 1 day. Is there a systematic way to convert my mental model? Yes, the reframe that works. Think of KQL like Unix or PowerShell pipeline. In Bash, you write cat file pipe to grab error pipe to sort pipe to head -10. Data flow left to right. Each command transforms what it receives. Same model here, same idea, but vertical. Table at top, then each operator is a transformation. Once you internalize, I am building my pipeline, not declaring a result, the rest clicks then quickly. The explain keyword is your best friend, by the way. With explain, you can write SQL, put -- explain before it, and the query set shows up in KQL. Or you can use all the beauty of modern large language models. Make series versus bin and +summarize. When to use which? I see two ways to time bucket aggregations. With bin, timestamp 1 hour, inside summarize, and make series. They seem to produce similar results. When should I use each? They look similar on the surface, but they produce different output structures and serve different purposes. When you use bin +summarize, there's a flat table, 1 row per group and time bucket. It skips time buckets where there is no data. It's simple, readable, and it's pretty naturally. Make series produces an arrow per row structure. 1 row per group with arrays for the time axis and value axis. It fills in missing time buckets with a default value. So this is required for detect anomalies, decompose forecasts, and all the series scalar functions. So different purposes. Decision rule: if your next step after aggregation is render, then use bin +summarize. If your next step is series decompose, or any other series function, then use make series. Next question, KQL Queryset versus Power BI for dashboards. I already have Power BI dashboards connected to my KQL database. Why would I use real-time dashboard plus KQL Queryset instead? Where does each one make sense? Both are valid, great architecture question. Real-time dashboards are designed for operational monitoring, like a TV screen showing your live data. Power BI reports are designed for analytical reporting. Slice and dice, executive dashboards, scheduled refresh, not sub-seconds, and so on. So rule of thumb, if someone asks what happens in the last 5 seconds, use real-time dashboards. If someone asks what happened last quarter, use Power BI, and somewhere in between the challenge starts. By the way, you can combine both. You use real-time dashboards for your operational live view and Power BI for the weekly trends analysis. Both are connected to the same KQL database, of course. Next question, sharing queries without giving database access. I want to share a KQL query with a colleague, but I want to give them access to my entire KQL database. Is there a way just to share the query result or read-only view? The simplest way is export everything as CSV directly from the KQL query results pane, no database access needed. For live shareable view, pin the query to real-time dashboard and share your dashboard. You control who has access, and it's separated from the database. For recurrent automated exports, use a Fabric pipeline or a notebook. For true read-only query access, the workspace roles matter. A viewer on the workspace can see the results but cannot open the KQL query editor. For finer grade control, by the way, KQL databases support database level permission scopes. Performance. My query is taking too long. My KQL queries on large tables are slow. What are the most common performance mistakes to avoid? First one, no time filter. Nothing with ago. It's just everything. So event house data is stored in time ordered extents, and the time filter helps on that. Project too late. Move project. The column selection as early as possible because they need to get rid of columns. Take without filter, storm events pipe to take 1000, scans arbitrary 1000 rows, not a substitute for a time filtered query. String has versus contains. Has word uses an index, is fast. Contains word does a full substring scan, is slow. Scanning with regex. Regex is expensive. Try starts with, or has, or contains first. Use regex only when necessary. Last question, can I use KQL queries in notebooks? I'm a data scientist. I live in Fabric notebooks. Can I use KQL from a notebook, or do I have to switch to KQL Queryset every time? Yes, you can. You have KQL Magic. It's a Python package. And then you can write KQL queries with the person KQL Magic operator. Very, very simple. Pitfalls, I think we talked about every one of them. Missing time filter requires a full scan. Using equals instead of equal. So double equals, KQL uses double equals for string comparison. Make series without from to range. And the pro tip, of course, use explain to convert your SQL queries to KQL, or use your favorite large language model. Let statements at the top of each query act as parameters. Change one value to adjust the whole query. That's quite nice. Press Shift Enter to run a query without leaving your keyboard. Right-click a table name in the Explorer pane, insert to scaffold a query template. Copilot in KQL Queryset can generate KQL from natural language. This is really, really great for learning. So this was the KQL Queryset video. Thanks for attending. When you want to get a notify once I release a new video every week, by the way, just hit subscribe on my YouTube channel. And hope to see you next time. Take care.